Hey everybody, welcome back. Alright, today we are talking about similar figures. We've just finished talking about congruent figures. Those are figures that are exactly the same. Similar figures are similar to each other but not exactly the same. Let's see what I mean. Similar triangles, they'd be the same shape but not necessarily the same size, so that means they could either be enlarged or they could be shrunk. For shapes to be similar, two things must be true. One, all the angles have to be of equal measurement, just like congruent triangles. Here's the difference. Corresponding sides do not have to be the same size, they only must be proportional. Let's see what that means. Notice here I have a large triangle and a small triangle. They are not congruent because they are not the exact same size. But they are similar because notice I have all three angles are the same. And you'll notice that when I put in my sides, all three sides are proportional. Let's see what we mean by that. Okay, look familiar? Good. So, if I look at my sides, I hope you notice that I have my little numbers, 10, 6, and 8, 10, 6, and 8 for my numerator, and my large triangle numbers for my denominator, 15, 9, and 12. Notice the hypotenuse for the small triangle is a 10, and therefore the number that corresponds with the hypotenuse is the number that's the hypotenuse for the large triangle, and that's the 15. Notice my 6 goes from the 57-degree angle down to my right angle, and my 9 is the corresponding side because it goes from the 57-degree angle right on down to my right angle. If you notice, the 8 is right here, and the 12 is right here. Notice how we get our corresponding sides? So what does it mean to be proportional? It means all these fractions are equal to each other. Are they equal to each other? Let's simplify and find out. If I divide this by 5 and this by 5, what would I get? If I divide this by 3 and this by 3, what would I get? And if I divide this by 4 and this by 4, what would I get? You got it, 2/3 on all of them. Notice, they are proportional because they are the exact same fraction. So, which rectangle is similar to rectangle A? By definition, a rectangle has four 90-degree angles, so they all have the same angles. Let's check it out. Notice how I use my short side and my long side? And I put my 3 for my short side and my 6 for my long side, my 2 for my short side, my 6 for my long side, and you get the idea. What happens when I simplify them? Notice what I get. Now can you tell which one is similar? You're right, it's these two. This isn't a bad rectangle, it's just not similar because it does not have the same proportion. What about this one? Pause right now if you want to give it a try on your own. Okay, I'm back. Notice I have my short side and my long side. Notice when I set them up, what's going to happen when I simplify? Makes it a whole lot easier, doesn't it? Any questions? All right, so now that we know how to figure out if something is similar to the next, once we know that they are similar, how can we use it to find an unknown side? Well, let's see. Hopefully you notice that I have my little triangle and my big triangle. So I have them set up. Notice, little triangle has sides of 6 and 8. Big triangle has sides of 9. Notice that one corresponds with the 6. And the unknown number corresponds with the 8. How do I solve this? Same way you learned last year. Cross multiply. I end up getting 6x equals 72. Divide by 6, divide by 6. Our one-step algebra coming back to help us out. And we get the answer x equals 12. How would I figure this one out? Notice I've got a little and a big triangle. So my big has a 9 and a 6. Hey, where'd you go? My big has a 9 and a 6. And notice the long side right here, the 6, corresponds here with the 9, and that's why I put the other 6 right over the 9. How do I solve this one? Cross multiply. And the answer is x equals 4. It's that simple. You guys can try this one. So once again, cross multiply. And I get the answer, 24. Hey, did anyone notice that 7 centimeters and 14 centimeters, well, that's just 7 times 2 is 14. And did you notice that 12 times 2 would have been 24? That's a very good shortcut if you noticed it. If you want to explore that more, come by and see me after school. Otherwise, this one method works every single time. How can I mess with you? Well, what if I rotate the figure? Do you still know which numbers go together? Notice we've got our little, and we've got the 5 corresponds with the 11. And you guessed it, answers don't always have to be nice numbers. The answer can end up in a decimal form or in a fraction form. It is perfectly legal. All right, so here's how we use this stuff in the real world. It's called indirect measurement. Now, if I was trying to measure this man right here, that would be easy. I'd have him line up against the door, I'd put a mark against the door, and I'd take out a measuring tape and I'd measure him. Or I'd have him lie on the ground and then I'd just mark his feet and I'd mark his head and I'd be able to measure him that way. The tricky part is, how do you measure the flagpole? I mean, it takes a little bit of work to get it onto the ground, but you can use indirect measurement to be able to measure that flagpole. First thing we do is we utilize the sun. The sun gives a shadow of the flagpole and also gives a shadow of the man. When we use that shadow, what's going to happen is we're going to get 2 triangles. Do you see the triangle of the flagpole? And do you see the triangle that the man makes? These are similar triangles. And if we think about those triangles, we're able to set up a proportion. Notice, the 3 feet of the shadow for the man and the 36 feet for the shadow of the flagpole are congruent. And the 5 feet for the shadow of the man would equal how tall the flagpole is. Cross multiply. And you could get your answer, 60 feet. Pretty easy, huh? You can also do things like measuring the distance across a river. Because without swimming across and carrying a measuring tape that might not be long enough, how in the world would we do something like this? What if there are crocodiles in there? Well, I hope you notice that these 2 triangles are similar. And so, if we measured this distance, 16 meters, this distance, 18 meters, this distance, 45, all on one side of the river, we could figure out the distance across the river. Notice, here are 18 and 16, and I hope you notice that the 18 would correspond with the 45 if you rotated this 180 degrees. How do you handle it now? Cross multiply. Did you notice what I did to make it a little easier? I simplified the 18 over 16 to 9 over 8. When I simplified it, I made it an easier problem. The other thing, did you notice that 9 times 45, or 9 times 5 would be 45? What's 8 times 5? You got it, 40. Notice the shortcut. All right, guys, that's it for similar shapes. I hope you found that they are valuable. And if you have any questions, make sure to stop by and see me in school. See you guys soon.